Hello, welcome to this video mini lesson on variations of ANOVA analysis. So ANOVA analysis, as you know, is the analysis of variance amongst two or more groups based on one independent variable. Now, our first variation of ANOVA is called Factorial ANOVA. And instead of focusing on just one independent variable, Factorial ANOVA focuses on more than one independent variable. And that's the difference between Factorial ANOVA and ANOVA, which is known as one-way analysis of variance. So if you have two independent variables, that would be a two-way ANOVA. If you had three variables, that would be a three-way ANOVA, etc., etc. Our second variation of ANOVA is what is called within subjects ANOVA. And this is a situation where, unlike regular ANOVA, you actually have dependent samples. So that could be the same subjects who are analyzed over time, such as a pre-post situation, or matched groups, such as sibling groups. And for any sort of dependent samples, you've got to use a repeated measures analysis, and within subjects ANOVA is an example of a repeated measures analysis. Our next variation of ANOVA is called MANCOVA, or analysis of covariance. So MANCOVA is good when either you're doing a post facto analysis, where obviously you couldn't offer randomization, or when randomization is unfeasible for whatever reason, okay? So in this sort of situation, if you don't have a randomized sample for your groupings, then you might have to control for some independent variable or variables. For example, in a lot of educational achievement studies, you often will control for students' prior performance, which actually can obviously influence their successive performance. So that would be an example of the kind of independent variable that you would control for in an MANCOVA analysis. Our next variation of ANOVA is MANOVA, or multivariate analysis of variance. And this is a situation where we have more than one dependent variable. So over here with Factorial ANOVA, we have more than one independent variable. Over here we have more than one dependent variable. And I'll show you an example of this in just a minute. And our final variation of ANOVA that we're going to be discussing is MANCOVA, which is multivariate analysis of covariance. So if you think about it, it's sort of a combination of MANOVA, because it's multivariate, you have more than one dependent variable, and it's sort of a combination of MANCOVA because you have to control for some independent variable or variables. So let's consider an example here. Let's say that we want to study the effects of an after-school math tutoring program. So we're going to have three groupings here. Group A would be in the program 3 times a week for 15 weeks. Group B has been in the program 2 times a week for 10 weeks. And Group C has not been in an after-school intervention participation or after-school intervention group at all. So they're our control. And our dependent variable is going to be their performance on the end of grade math test. So if we're doing just a basic ANOVA here, our independent variable would be the grouping, our dependent variable would be their performance on the EOG. Simple as that. However, if we want to consider Factorial ANOVA, we would be including a second independent variable. So our first independent variable would still be the grouping, which is essentially how much sort of tutoring they had. And the second independent variable might be their attendance in whatever grouping they've got, because we might be thinking that, you know, they might be in Group A, but if they're only showing up half the time, their performance might be substantially different than someone who's in Group B, but who actually shows up all the time. So attendance in the tutoring program would be our second independent variable, because it too, like grouping itself, might be influencing our dependent variable, the student's performance on EOG math tests. Let's consider within subjects ANOVA. We might want to use the same students and do both a pre-post test of their math achievement. So we might want to test them before they start their tutoring program and after they start the tutoring program. So we would still have our same groups. We would just be adding this extra element of our analysis, and that would be by pairing our subjects, so doing same subjects over time using a pre-post test of math achievement. If we wanted to do a situation where we felt like we needed to control for students' prior performance, then we might want to use an MANCOVA and control for the independent variable of students' prior performance. So we might use their last year's EOG math scores, end of grade math scores, as that variable, that independent variable that we want to control for, because we might realize that their prior performance might be heavily influencing their successive performance on the current year's EOG test. Now let's say, for example, that we wanted to actually look at two dependent variables here. So not only did we want to look at their end of grade math test score, but we might also want to look at their math grade in their math class. In that case, we would use a MANOVA analysis because we now have two dependent variables, two different variables that could be affected by the grouping, by which tutoring opportunities students had. And then our last option here is MANCOVA. And in this situation, we would both use both of our independent variables here, or excuse me, both of our dependent variables here, the end of grade math test scores and their math grade in class, and we would also control for the group's prior performance using their end of grade math score from the previous year. So this is an example on one sort of line of inquiry that we've got here, and how, depending on how you wanted to examine that inquiry, how you wanted to design your research, you might use one of these different variations of ANOVA. As always, if you have any questions, please let me know. Thank you.